So, oops. All right, let's go over these problems. If you didn't finish, don't stress. Don't stress. It's okay. Remember, today is Support Monday. Support Monday. So this is a day to catch up on anything. So if you didn't do the homework, it's okay because it's not due till tomorrow. Okay, so the homework is due tomorrow because we haven't really finished going over everything. And then today we're not going over everything new. I just want to go over the multiplying part. If you'd missed any warm-ups last week, let's say you were absent or you just didn't do it, or for whatever reason, you can always go back to Desmos and you can check your activities and you can always go back. There, I open them back up. So Monday is a day it's a day that if you hit any bumps in the road last week, you can regain your composure. You can get up, you can fix yourself, you can get back on track, whatever you need to do to make sure you're on the right track. So that's what today's all about. But let's go over these multiplying. Okay, there we go. Sorry about that. All right, so the first one was a binomial times a binomial. Okay, so we said there's a couple ways to do this. So we have x minus 8, x plus 4. Now, if you want to do FOIL, you can. You can do FOIL, which says multiply the first ones. Now, remember, FOIL only works binomial times binomial. So we can do the first, which is x times x, which is x squared. Remember, x times x is x to the second power. When you multiply variables, you add the exponents together. Okay. And then we have x times 4, the outside ones, which is 4x. And then we'll do the inside ones, right? FOIL is first, outer, inner, last. So we did the first ones, x times x. Then we did the outer ones, x times 4. Now let's do the inner ones, negative 8 times x, which is negative 8x. And let's do the last ones, negative 8 times positive 4 is minus 32. Okay. Combine like terms, so the ones in the middle are alike because they have the same variable with the same exponent. I cannot combine the x squared with the x's because that has a second power and this has a first power. Okay, so I can't combine those because they are not like terms. So it says x squared plus 4x minus 8x is negative 4x minus 32. Okay, so that's FOIL. Now, I told you we were going to talk about it, and I wanted you to look over this weekend, and some of you are like, oh, that's right, I forgot. It's okay. It's okay. Don't stress. We forget things. I forget all the time. The area model or the box method, and here's what I do. So I have a binomial times a binomial. Binomial means two terms times two terms. And like I said, everything in this binomial has to multiply with everything in this binomial. So what I do is I'm going to make a box. Okay. And I'm going to cut one side into two pieces because I have a binomial, and the other side into two pieces because I have another binomial. And I'm going to put the binomials as the side lengths. So x minus 8, right? You see x minus 8. I'm going to put x and the minus 8 because if you add those together, it's x minus 8. The other side, I'm going to put x plus 4. I'm going to put my x and positive 4 because if you add that side together, it's x plus 4. And so I'm just going to multiply like a Punnett square. Right? So what goes in this box right here? Well, x times x, which is x to the second power. And then x times 4. X times 4 is 4x. And then negative 8 times x is negative 8x. And negative 8 times 4 is negative 32. And so now I have a nice, neat little box. I just combined the like terms, and I said, oh, okay. That's an x squared. These are x to the first powers, and that's a constant. So that my answer is x squared minus 4x, because I just combined these, minus 32. There you go. Same answer, different method. Any questions on the box method? Any questions on the box method? No questions at all? I like the box method the best because it's nice and compact. It's organized, and it works with any polynomial times any polynomial. That's what I like about it. Okay. Any questions? Is there like a more neat way to do it? Well, this seems the neatest, right? All your answers are in this box, right? Yeah, it's a more neat way to do it because it's in the box, right? I mean, FOIL, not horribly unneat, but again, FOIL only works for binomial times binomial. And if we just do distributive property, like if we look at the next problem, right? If we look at the next problem, which is x squared minus 4x, it's a trinomial, plus 3 times 3x squared plus 5x minus 10. So if I did distributive property, because I can't do FOIL, can only do FOIL binomial times binomial. If I do distributive, I have to get this term and multiply to all 3. So I'd have 3 things. Then I'd have to get this term and multiply it to all 3. So I'd have 3 more things. And then I'd have to get this term and multiply it to all 3 things. And then I'd have 3 more things. Then I'd have 9 things in a long line. It can look messy. It can get rather disorganized. So here's what I suggest. If you have a trinomial, if you have any polynomial times any polynomial, I'll make a box. Okay, so if you notice, I have a trinomial and a trinomial. I have 3 terms and 3 terms. So I'm going to make a box that's 3 on one side and 3 on the other. So I'll make a box like this. 1, 2, 3. 1, 2, 3. So on one side of the box, I'm going to put one of the polynomials. X squared minus 4x and 3. So that whole side represents the polynomial. Then the other side is going to represent the other polynomial. 3x squared, 5x, and minus 10. And so what I do, I just multiply like a multiplication table, right? Like a Punnett square, to get the values of each box. And then I'm just going to add the boxes together to get my answer. Nice, clean, and there's still 9 boxes, right? There's still 9 terms I'm going to have, just like if I did the distributive property. But it's a nice, organized way. And if I put it in descending order, see how this is squared, first power constant, squared, first power constant. If I do it like that, this is going to become a lot neater for me to combine like terms too. Watch, let me show you. So let's do this. So x squared times 3x squared, right? So multiply the coefficients. 3 times 1 is 3. X squared times x squared is x to the 4th. Remember, when you multiply variables, you add their exponents. All right, let's go to the next one. X squared times 5x. So this becomes 5. And then x times x squared is x to the 3rd power. All right, next, x squared times negative 10. That's easy. Negative 10x squared. All right, next line. Negative 4x times 3x squared. Well, multiply the coefficients first. Positive 3 times negative 4 is negative 12. X times x squared. Add the exponents. X to the 3rd. Next, negative 4x times 5x. Multiply the coefficients first. Negative 4 times 5 is negative 20. X times x is x to the 2nd power. Next, negative 4x times negative 10. Well, negative 10 times negative 4 is positive 40, and then x times, there's no variable there, it's just x. Last line, we have 3. So 3 times 3x squared is 9x squared. We have 3 times 5x, which is 15x. And then we have 3 times negative 10 to give me negative 30. Nice, neat box. Everything's nice and compact. It doesn't take up a whole bunch of space. It looks so organized. So now, here's what I told you. Because I put it in descending order on each side, you can see diagonally. Once you put because how do you know to put them in order? Highest exponent to lowest exponent. So someone asked in the chat, Mr., but once you have all your numbers, how do you know how to put them in order? Remember, we talked about standard form. Standard form was highest exponent to the lowest exponent. So if you look here, highest exponent, next highest exponent, constant. Highest exponent, next highest exponent, constant. Now you'll see everything inside is organized. Fourth power, third power, second power, first power, constant. See that? Fourth power, third power, second power, first power, constant. So I just combine those diagonals and I'm done. So let's do fourth power. So there you go. There's only one. So it's 3x to the fourth power. Now let's look at third power. Let's combine these. Negative 12x cubed and positive 5x cubed becomes negative 7x cubed. Next, let's look at all the squared. Second power. Oh, they're all right here. So we have negative 10x squared minus 20x squared. So these two become negative 30x squared. And then we add 9. So negative 30 plus 9 is negative 21x squared. Now let's go to x to the first powers. Oh, they're all right here. 40x and 15x, put those together. They're both positive, so it's plus 55x. And then at the end, I only have one constant, minus 30. It is that simple. Yep. Okay, there you go. Questions? Any questions on how we do the box method? So the whole key here is when I'm multiplying polynomials, I want every term in one polynomial to multiply to every term in the other polynomial, and there's easier ways to do it and more difficult ways to do it, right? We can just say, okay, multiply that to everyone over here, multiply that to everyone over here, multiply that to everyone over here, and then you have a big long line. And some of you are like, I'm okay with that, mister. Some of you are like, I like distributive property. Leave me alone. So I'm like, okay, more power to you. You'll have all of these terms, but they'll all be in one long line. Or you can organize them in a box and do what they call the area model. And then one side represents your polynomial, cut it into the individual monomials. Same thing to the other side. And just multiply like a Punnett square. And then it's nice and neat to combine everything at the end. That's my recommendation, but if you want to do it the other ways, that's fine. Again, you can't use FOIL on this trinomial times trinomial because it only works for binomial times binomial. All right, any questions? Any questions? I never realized that in the end they are like that. Well, yeah, if you can do it, if you organize your sides the right way, the middle is a lot more organized. Yeah, I remember that moment in high school and I'm like, oh my God, they're all organized. This is going to make my life so much easier. And I was running around the hallways dancing and they're like, hold on, this is what they were yelling at me. So I'm running around the hallways. Whoa, did you guys know? And they're like, nerd! Yeah, so I don't care. I liked it. All right. No questions? No questions? All right, so here's what we're going to do the rest of the period. We have about 20 more minutes of the period. You are going to make sure you understand everything from, where is it? Here it is. Everything we talked about last week, monomials, polynomials, classifying and naming by degree and number of terms, how to add and subtract, what combining like terms means, and now how to multiply. How to multiply. Okay, and then tomorrow we're going to talk about special products. Like you're going to see two things being multiplied and you're going to know the answer like that without having to do any work because you're going to recognize some what we call special products like conjugates, squaring a binomial, and cubing a binomial. There are some shortcuts. Okay, but we'll talk about that tomorrow because that's new and we don't do anything new on Mondays. That's your Pacheco guarantee. Wait, let me say that again. That's your Pacheco guarantee. There you go. So are there any questions? Any questions? All right, so this is the time to work on your homework. Ask me any questions. Go back and do your warm-ups from last week if you didn't do them because I am going to be putting those in the grade book today. Monday is a day for me to catch up on grade book, and I need to catch up on this period. So I will be doing that. I'll be putting the warm-ups in from last week in the grade book. Homework will be due tomorrow night because we haven't finished the notes, because I do want to go over the special products. And this will be your warm-up tomorrow, just a little clue.